So in the last class, we started with the matrices. First of all, introduction to matrices. That matrices is a rectangular array of numbers within square brackets. Then a standard appearance of a matrix is like this: Aij, say of order 3 by 3. This order can be 2 by 3, 5 by 3, 1 by 3, anything can be. And then we have done a question. Then I taught you what is row matrix, column matrix, horizontal matrix, vertical matrix, and then there comes square matrix. Like this is a square matrix of order 2 by 2. 2 by 2 stands for 2 rows and 2 columns. Then it is a square matrix of order 3, 3 rows and 3 columns. A11, A22, A33 are called diagonal entries. Some of the diagonal entries is called trace of the matrix. All right. Aij, where I is not equal to j, they are called off diagonal entries. Aij, where I is not equal to j, are called off diagonal entries. And Aij and Aji, they are called conjugate entries. I told you conjugate entries has nothing to do with conjugate what we have done in the complex number chapter. All right. Then Then square matrix I taught you. What is upper triangular matrix? What is lower triangular matrix? What is a diagonal matrix? Then scalar matrix, where all the diagonal entries are A. Then unit matrix, where all the diagonal entries are 1. Then I told you the feature of diagonal matrix is like 1 of the algebra. Then there comes null matrix. Then we have covered equality of matrices. So two matrices are equal if they are of the same order and corresponding entries will be same. All right. Then we have done addition of matrices, subtraction of matrices, then multiplication of matrices by a scalar, and then we have done certain number of questions over it. All right. Is there any issue, any doubt anybody is facing or want to ask something? Please raise your hand or ask your doubt, please. Anyone? Because moving forward will be a little more difficult unless we understand the concepts we have done till now. Anybody who wants to ask something, please. I again repeat, is there anybody who wants to ask something? Fine. Sure. Now I'll start. Very good. Thank you, Gautami. Now we will do product of two matrices. Product of two matrices. So what about the product of two matrices? See, whenever we multiply two matrices, product of matrices is not simply like product we do in algebra. All right. So product of matrices is not simply what we do in algebra. So if there are two matrices, say AB, their product A is what we call prefactor. And B is what we call post factor. Prefactor and post factor. All right. Say A is of order M cross N, P is of order P cross Q. A is of order M cross N and P is of order P cross Q. In that case, first of all, matrix multiplication is not that we can do every time. All right, like in this case, product of matrices can be done product of two matrices can be done only if number of columns in prefactor is equal to number of rows in post factor. Means unless this n is not equal to this p, you cannot multiply these two matrices. So this n should be equal to p. This is a necessary condition. So once it is done, a resultant will be a matrix. Of order m cross q. Means resultant will be prefactor का number of row and post factor का number of column will be the order of the resultant matrix. Am I clear? Anybody? So only if this situation will occur, you will be able to multiply two matrices. Fine. Is this okay? Now how do we go with the matrix multiplication? First of all, before that, I'll ask you a small question. This is matrix A, this is matrix B. You are going to tell me if AB will exist or not. Then you are going to tell me if BA will exist or not and what will be their order. Say A is of order 2 by 3, B is of order 4 by 5. Are we able to do a map product AB? Tell me quickly. Anybody can switch on their mic and speak up? No. Are we able to do product BA? Again, no.
No.
Okay. If fine. Now take another example. Say this is of order 2 by 3. This is of order 4 by 2. Are we able to do AB? Tell me quickly. No.
BA, sir.
AB we won't be able to do. Are we able to do BA? Yes. See, B is of order 4:2. A is of order 2:3. So this 2 matches. Now the prefactor is B. So the resultant you get here, BA, will be of order what? 4:3. Am I correct? Now, say this is of order 2:3. This is of order 3:2. Are we able to do AB? Quickly, yes. And the AB you get will be of order 2 by 2. Are we able to do BA? Yes. And order of BA will be 3 by 3. Got it? So first of all, this is about the order. Fine. Now, how do we actually multiply them? I'll take small example. Say A is of order. A is the matrix. A is of order, say 2 by 3. B is of order 3 by 2. Fine. Now AB. I will make A as A11, A12, A13, A21, A22, A23. Then B. B is of order B11, B12, B21, B22, B31, B32. Now see very carefully how do I multiply it. First of all, I know the resultant will be of order C. This is of order 2 by 3. This is of order 3 by 2. The resultant will be of order 2 by 2. Clear? So first of all, what we do, first row, first column will give element of first row, first column of the resultant matrix. So multiply these two. A11 B11 plus A12 B12 plus A13 B31. Fine. So this is A11 B11 plus A12 B21 plus A13 B31. Everybody understood? Raise your hand or you just raise your thumb if you understood it. Now, first row, second column, whenever I multiply these two, first row, second column, I will get the element of first row, second column means this element of the resultant matrix. Now it will be what? A11 B12 plus A12 B22 plus A13 B32. Correct? Then second row, first column. So it will be A21 B11 plus A22 B21 plus A23 B3. Then second row, second column. So it is A21 B12 plus A22 B22 plus A23 B32. So this is your resultant matrix. Understood? Now, suppose if we want to find BA. Now, what is B? B is B11. B is B11, B12, B21, B22, B31, B32. Just a moment. Just a moment, my screen hanged. So we were trying to find BA. B11, B12, B21, B22, B31, B32. Multiplied by A11, A12, A13, A21, A22, A23. All right. Now see, this is of order 3 is to 2. This is of order 2 is to 3. So certainly the resultant that I'm going to get will be of order 3 by 3. Resultant will be of order 3 by 3. Now, first row, first column, their product will give you first row, first column element of product. So that would be B11, A11 plus B12, A21. Correct? Then first row, second column, B11, A12 plus B12, A22. Then B11, A13 plus B12, A23. All right. Then anybody switch on their mic. Tell me what will be this element. Anyone? Tanush? Abhishek? Anybody? All right, nobody wants to speak. Second row.
B21.
B21.
A11.
A11
A11, very good.
plus B22
Plus B22.
A21.
A21.
21.
Second.
B21
B21 A12 plus
plus
B22 A22.
A22.
Third, B21 A13 plus B22 A23. Then come to third row. B31 A11 B32 A21. B31 A12 B32 A22. B31 A13 plus B32 A23. Am I correct? Is this okay, everyone? Well, now let's take an example. Now you will multiply these two determinants. 1, 2 minus 1, 3, 2, 4, 1 minus 1, 4. It should be multiplied by 4, 1, 0, 0, 2, 3, 3 minus 1, 2. Yes. What is the resultant? Everybody quickly find it. And I give you a couple of minutes. So quickly find it and tell me the correct answer. Priya, can you hear me? Priya? Abhishek? Yes, anybody who want to speak up?
Sir, I think it's 1.
Sorry?
Sir, 164.
164, first row or first column?
Sir, first column.
First column, 164, all right.
Sorry, sir, first row.
First row, 164,
24,
24,
3,
3,
14.
14, right?
Yes, sir.
164, 24, 3, 14, and
16
16
minus 5, 5.
minus 5, 5. All right. Anybody having any issue with any of the element? I think third row, second column, it will be 1, minus 2, minus 4. Yes, minus 5 corrected. Then first row, third column is minus 3 plus 8 plus 5. Yes. All right. Anybody facing any problem for any element? See, I did not calculate it. I was expecting you guys to calculate it. Yes, quickly. Anybody? Now see, this is how we multiply two matrices. Now, properties of matrix multiplication. Properties of matrix multiplication. First property is matrix product is not commutative. Means AB is not equal to BA. Sometimes it can be, but in general, product of two matrices is not commutative. See, you have seen the cases where AB may exist, BA may not exist. Where AB and BA both are existing, but both are of different order. Or another possibility is AB is existing, BA is existing, and they can be same. Even if they are of same order, AB and BA are different. And in rare of the rarest cases, if AB is equal to BA, sometimes it can be, but in general, what the statement is that matrix product is not commutative. So, first property. Second is matrix product or matrix multiplication is distributive. Distributive. That means if you multiply A with B plus C, sum of two matrices, you will get AB plus AC. One thing I would like to bring to your notice, take care of the order in which matrices are given. Sometimes what students do, A times B plus C is AB plus now they write CA. This is not correct. Since A is a prefactor, it will remain a prefactor only. Am I correct? Now, third property. Property number 3. Matrix multiplication. Matrix multiplication is associative. So A times BC is AB times C. Means you first do BC, then multiply with A, or you first do AB, then multiply with C. It does not make any difference. All right. Fourth property. See, if sometimes you see that AB equals to AC, that does not imply that B equal to C. If AB equals to AC, that does not imply that B equal to C. But if B equals to C, that definitely imply that AB equal to AC or BA equals to CA. Means to an equality, you can multiply any matrix as a prefactor or as a post factor anytime. But you cannot delete any matrix from already multiplied equation. And here also, if B equal to C, that does not imply that AB equals to CA. Means if you are multiplying with A, either keep it as a prefactor both sides or keep it as a post factor both sides. But it should not be like you keep it as a prefactor one side and post factor another side. Am I clear? Now, fifth property. If any matrix is multiplied with an identity matrix, it remains same. You multiply identity matrix as a prefactor or as a post factor, it does not make any difference. All right. Sixth property. There are certain properties of matrix multiplication which are correlated with the determinant. So we won't cover it right now. We'll cover it later on when the determinant will be done or along with the determinant. Next. Now, see if you are doing A plus B whole square. it is not directly a square plus b square plus 2ab. Similarly, if you are doing a minus b whole square, it is not directly equal to a square plus b square minus 2ab. Why so? Because the main issue is, see, what is a plus b whole square? That is a plus b into a plus b. So it will come out to be a square plus ab plus ba plus b square. So I will call it a square plus b square plus 2ab only if ab and ba are same. Means only if matrices A and B commute, then we can write it 2ab. Otherwise, in general, it is a square plus b square plus ab plus ba. All right. So if we write sometimes that a plus b whole square is a square plus b square plus 2ab, possible only if a and b commute each other. Otherwise, we will use this particular one. All right. Now, similarly, if you do a minus b whole square, it will be a square minus ab minus ba plus b square. Similarly, if I do a minus b into a plus b, don't directly write it a square minus b square, whereas it will be equal to a square plus ab minus ba minus b square. Because matrix product of two matrices is not commutative. Am I correct? Is it fine? So this is sixth property. Okay, now let's do a seventh property. Sometimes if you are doing, say, a to the power 4. So this a to the power 4 is simply a. Means multiplying a with itself 4 times. So isko we can also write a square a, or you can also write a square a, or you can also write a cube. However you want to write it, that is fine. There is no issue with that. All right. Anybody having any issue till now? Is it okay with everybody? Fine. Now eighth property. This is what we call matrix polynomial. Matrix polynomial. Say let there is some polynomial fx, that is a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on, a n minus 1 x plus an. Okay? Then matrix polynomial is defined as f of a, where a is a square matrix. So f of a will be a naught a to the power n, a1 a to the power n minus 1, a2 a to the power n minus 2, and so on, a n minus 1 a plus a naught. All right. Now, this a naught cannot be left blank. So we multiply it by I. All right. So see, a matrix cannot be added to a scalar. So what do? We multiply that finally left scalar with an identity matrix of the same order. Fair enough? So this is what we call matrix polynomial. Like, write down a simple question. The question is, the matrix A is 1, 2, 2, 2, 1, 1, 2, 2, 1. Be a zero divisor of the polynomial fx equals to x square minus 4x minus lambda. Find the value of lambda. Hence, find trace of AQ. Hence, find trace of AQ. So, first of all, there is a new term which might be new for you, zero divisor. Zero divisor means if I place this matrix into this equation after making it matrix polynomial, this will satisfy. So what will be matrix polynomial? First of all, matrix polynomial will be f of A is A square minus 4A minus lambda I. And since it is a zero divisor, it will satisfy and it will become a null matrix. So first of all, we will calculate A square and then 4A we will subtract and then I'll compare to get the value of lambda. All right. So what is A square? A square is 1, 2, 2, 2, 1, 1, 2, 2, 1 multiplied by 1, 2, 2, 2, 1, 1, 2, 2, 1. So this is what? This into this. It will be 9. Then this into this 2 plus 2, 4 and 4, 8. This is 8. Then this into this 2, 2, 2, 6. All right. Then this into this. This into this will be 2, 2, 2, 6. This multiplied by this 4 and 1, 5 and 2, 7. Then this into this 4, 1, 5, 1, 6. Then this into this 2 plus 4 plus 2, 8. Then this into this 4 plus 2, 6 plus 2, 8. Then this into this is 4 plus 5, 6 plus 1, 7. This is your A square. So whenever you do A square minus 4A, what do you get? That means 9, 8, 6, 6, 7, 6, 8, 8, 7. Minus 4 times A. A is 1, 2, 2. I directly multiply 4 inside. So it will be 4, 8, 8. Then it is 4 to the 8, 4, 4. Then 2 4 the 8, 8, 4. So with this subtraction, what do I get? 9 minus 4, 5. 8 minus 8, 0. 6 minus 8, minus 2. 6 minus 8, minus 2. 7 minus 4, 3. 6 minus 4, 2. Then 8 minus 8, 0, 0. 7 minus 4, 3. All right. So there is, because it is not equal to, it cannot be equal to some lambda I. What is lambda I? Lambda I basically lambda 0, 0, 0 lambda 0, 0, 0 lambda. All right. So this equality won't hold in any case. I check one more two calculation once again. This is 2226 is okay. Everything is fine. That means there is no such lambda. There is no such lambda exists. That means there is no such lambda exist. Is everybody okay with this question? Fine. Now another question. Now a very simple question for you. I want everybody to participate and give me the correct answer. Product of n matrices. Product of n matrices 1, 1, 0, 1 into 1, 2, 0, 1 into 1, 3, 0, 1 and so on 1 and 0, 1. If this is equals to 1, 378, 0, 1, then find the value of n. All right, give it a try quickly, everybody. Yes, anybody? See, in the question, if you notice, they are not expecting you that you multiply all the n matrices, isn't it? Definitely, it is not feasible also. So there might be certain pattern when you start multiplying them. Like if I multiply 1, 1, 0, 1 with 1, 2, 0, 1. That is what? First row, first column 1. First row, second column is 1 plus 2. Second row, first column 0. Second row, second column 1. Am I correct? Now you are multiplying this 1, 1 plus 2, 0, 1 with the third matrix 1, 3, 0, 1. So what do you get? First row, first column 1. First row, second column is 1 plus 2 plus 3. Second row, first column 0. Second row, second column is 1. So this is how it is going, that A1, 2 is getting actually added. That means this entire matrix, this product will be 1, 0, 1 plus 2 plus 3 से लेके n up to 1. So it will be 1. This summation I know, this is n into n plus 1 by 2, 0, 1. Now if this is equal to this one, that means n into n plus 1 by 2 is equals to 378. Am I correct? This n into n plus 1 by 2 is 378. That means what? N into n plus 1 will be 8 to the 16, 14 and 1 15, 3 to the 756. Now either you solve this quadratic or you can try different values of n to get a certain answer. I assume n should be 26 or 27 and 7. And will be 27 if you simplify it. You just need to find the two consecutive numbers whose product is 756. So like 20, if you check, that is 20 into 21, which is 420. So less than 756. And if you check 30, that is 30 into 31, which is more than 900. So your answer is somewhere between 20 and 20 and 30. Now if you check for 24, so it is 24 into 25. That would be 600. So answer is little more than that. So you just you can check it using heat and trial and reach the exact conclusion. All right. Am I clear? Anybody please speak up. That would be a boost for me also.
Yes, sir.
Very good, Lakshmi. Thank you so much. Lakshmi, you are from which JNB?
JNV West Godavari, sir.
West Godavari. Okay. Are you understanding everything? Is it fine?
Yes, sir.
Are you liking the class?
Yes, sir.
Okay. You got your 11th class marks? Lakshmi, don't worry. I won't ask. I won't ask in front of everybody how much did you score. I'm just asking, did you get your 11th marks?
Yes, sir.
So satisfied?
Yes, sir.
Chalo, very good. And the only thing I would say, work harder.
Okay, sir.
This is the prime of your time. Now the next question. See, if alpha and beta are the roots of the equation, are the roots of the equation, alpha and beta are the roots of the equation. Say this is a matrix 1, 25. This is matrix of order 1 into 2. Then it is 0, 1 by 2, minus 1, 1 by 2, raised to the power 5. Then it is 1, minus 1, 2, 0, raised to the power 10. Then it is 0, 1 by 2, minus 1, 1 by 2, raised to the power 5. And then it is x square minus 5x plus 20, x plus 2. And this entire equation, this product is 40. Then they're asking for find the value of 1 minus alpha into 1 minus beta. All right, give it a try. This is basically minus 1 by 2. It is small change. There, I changed minus 1 by 2. Just a minute. It's fine. It is the way it is. Yes. Give it a try. Quickly. See, there is a small catch. Very good question it is. Let us assume your matrix A is 0, 1 by 2, minus 1, 1 by 2. And your matrix B is 0, minus 1, 2, 0. Can somebody tell me what is AB quickly? This is 1. Yes, can somebody tell me what is AB? Anybody quickly? Hemant, Lakshmi? Product, you know? What is AB? Abhishek?
Sir, I think it's 1011.
Yes. 1, 0, 1, 1, nahi, 0, 1. And similarly, if you check BA, that is also 1, 0, 0, 1. So they both are identity matrix. Yes or no? Now you see this equation in between. You just see this thing. What is this? Isn't it a to the power 5, b to the power 10, a to the power 5? That would be a 5 times. Then B 10 times, and then again A 5 times. All right. First of all, this B into A will multiply, will give you identity matrix. This A into B will multiply, will give you identity matrix. So what will happen in that case? 4 times A left, 8 times B left, and again 4 times A left. Again, this BA will merge, this AB will merge, and this will keep on going. And ultimately, what do you get? You will get an identity matrix. So the major catch in this is that this in between will become an identity matrix. So what you are left with? 125, which is of order 1:2, into x square minus 5x plus 20 x plus 2, which is of order 2 into 1. And if you multiply them, you get a matrix of order 1:1, which is a single entry matrix. That would be this multiply by this. So it will become x square minus 5x plus 20 plus x plus 2. And they are saying this is equals to this 1:1 matrix 40. That means this x square minus 5x plus 20 plus x plus 2 is 40. So it will become x square minus 4x 22. So minus 18 equals to 0. This is the equation you got. Fine. Now, what they're asking you is its roots are alpha and beta. So they're asking you 1 minus alpha, 1 minus beta. So it is 1 minus alpha plus beta plus alpha beta. So 1 minus alpha plus beta is 4. And in just a moment, did I make some mistake? Okay, this is basically 25x plus 50. 25x plus 50. I did not see that. So this entirely goes wrong. So plus 20 plus 25x plus 50. This is equal to 40. So now what equation do I have? X square plus 20x plus 30 equals to 0. Its roots are alpha and beta. Correct? So now they are asking for 1 minus alpha, 1 minus beta. That is 1 minus alpha plus beta plus alpha beta. That is 1 minus of minus 20 plus 30. So your answer is 51. Somebody gave 51 few minutes back. JNV Navsari. Very good. Who's there from JNV Navsari? JNV Navsari. Am I audible to you? Can't you switch on your mic? All right, but very good attempt. Very good. All right, students. So that would be all from my side for today. In the meantime, you can attempt your NCERT exercise 3.2. Okay. So NCERT exercise 3.2. That would be all. So in tomorrow's session, we will start with the basics of determinant, how is 2 by 2 determinant, 3 by 2 determinants, their basic properties, and how do we solve them. All right. So that would be all from my side for today. And before ending the session, I would like to ask you to just mark your small feedback about the session.